Today we're going to look at Unit 9, Section 2, which deals with Venn diagrams. The idea behind a Venn diagram is to show the relationship between sets of data and how they interact with each other. So this example here, all students like football or baseball, and some like both. So here's the students that like football. The circle represents them. This circle represents the students who like baseball. And notice how the circles intersect. Some like football or baseball, but there's the intersection, some like both. Now, this Venn diagram shows a relationship between students who like Chipotle and McDonald's. And this box represents the students who don't fall into either circle. In other words, you have students, here that don't like Chipotle, don't like McDonald's. These students like McDonald's. These students like Chipotle. Those students like both. The intersection of two sets is called AND. A and B. And notice the word intersection. It's where they intersect. So A and B. That's the symbol. It looks like an upside down V. Also, it looks like the letter A. And. This is the intersection. This data. Those who like A and B is here. Students who like Chipotle and McDonald's. Right here. These students like both Chipotle and McDonald's. The union of two sets is called OR. A or B. Now this one is a V. A or B. It is the union of both sets. What is in both sets? All of A or all of B. It's what's in both data sets. You like A or B. Students like McDonald's or Chipotle. So it's all of the Chipotle circle and all of the McDonald's circle. So it's both. That's the union of the two circles. Now, when we're looking at data sets, if we just want one data set, you represent it by its letter or whatever it's dealing with, McDonald's, Chipotle, and so forth. So A, this is data set A. So if I just want A, I want the whole circle. If I want B, I want the whole circle B. So I want all the data that's in there. Students who like Chipotle. So that's the Chipotle circle. Use not to exclude a set. Not A. Not A. Not B. So if I'm looking for not A, well, here's A, right? So I want everything that isn't A. So I don't want any of that circle. So not A is here. That's not A. Not B, I don't want circle B. That's not B. Let's look back at our other example. students who do not like McDonald's. So here's the McDonald's circle. Everything but that circle. Everything but McDonald's circle. Now, we also need to know some information on how to construct Venn diagrams. So some keywords are some, all, and none. Some means there's an intersection between two data sets. Some students like McDonald's and Chipotle. There's an intersection. All means one set is completely inside of another. So you have one circle with another inside of it. All of this circle is inside of this. None means the two data sets have nothing in common. So you have one data set, another data set over here. Nothing in common. Let's construct a Venn diagram. Let's see the information we have here. Some triangles are acute. Some triangles are obtuse. No triangles both acute and obtuse. Some triangles are equilateral. Notice it's always saying triangles. So I'm going to go ahead and make a big box. This big box represents triangles. Some triangles are acute. Okay, so I'm going to draw a circle, label it acute. Some triangles are obtuse. But notice the next statement, no triangle is both acute and obtuse. So my obtuse circle doesn't intersect with the acute. Some triangles are equilateral. I believe this is missing a word. This actually should say some acute triangles. That's missing a word. Some acute triangles are equilateral. No, I'm sorry. That's incorrect. It should say some equilateral triangles I'm sorry, I'm messing this up. This statement is incorrect in general. Some triangles are equilateral. Yes, that's true. But it should say all equilateral triangles are acute. So inside of our acute circle are equilateral. Sorry for that mistake. Next class we'll continue with notes dealing with logic.